Okay, so the topic that we're talking about for the next little while is permutations and combinations. It's really quite interesting and fun, but it is also really difficult. It starts off quite easy, but then it just gets a bit of a confusing mess at times. So I'm just going to have to think really carefully about it. Well, the first thing I'm going to talk about today is how many ways can we order n distinct objects in a line. So I'm going to just start off with maybe something real easy. Okay, I have these two pens here. How many different ways can I order them in a line? So, yep, two, yeah. So we could go blue, orange, or orange, blue, right? So here's our options. Blue, like that. So far, so good, right? Okay, now let's add into the mix purple. How many ways could I have with 3 objects? Okay, yes. 6, okay. Why is it 6?
Well, we can have 2 with 2, and then we just we can do 3 times 2.
Yeah, okay, very good. So 3 times 2 is 6. So what Amrit is perhaps thinking of here is we could go here, here, or here. Yeah, that's 3. Does that make sense? But then, so that's for this one, isn't it? Here, here, or here. But then for this one, it could also be here, here, or here. So that's 6 in total, right? So do I have to draw those out? No. Okay. So 6 in total. And let's say we add red to the mix. How many ways? Are you with me on this or not?
Yeah.
Yep. Okay. How many ways?
You've lost me.
Okay. Fine. Okay. Fine. So let's actually write this out. So you've got 2 ways with 2, right? Let's do with 3. Okay. So we could have purple, blue, orange. Blue, purple, orange. Oh, this is so slow. Okay. Or go away. We could have right. Purple last, orange, okay, and blue.
No.
How's that? Okay, that's 3. Are there another 3 ways we could go at this point? Well, remember we've got them in the blue-orange order, so we could also go, alright, let's have the orange one before the blue one. So we could have purple, orange, blue. Okay? Or we could have orange, purple, blue. Or we could have orange, blue, purple. And those are the only options. Right? Okay, so now we've got those options. We want to add a 4th colour to all of this. What are we going to do when we add a 4th colour? So for each of those different options, I'm just going to leave it up with the first one here. Purple, blue, orange. Let's say we're adding a...
We were adding red.
We were adding red, okay. Here we go, here's red. Alright, okay, so we add red to this. You can see that red could be added here. 1, 2, 3, 4. So I've done 4 ways for this. And you can see that there's going to be 4 ways for this, 4 ways for this, 4 ways for this, 4 ways for this, and 4 ways for this. So it's going to be 4 times 6. So there'll be 24 ways. Okay? Can I please not write those ones down? Okay.
No way.
Okay, so 4 ways. Now if we add the next one, right? What are we going to do? So we've got 24 for this, 24 ways. Why are we looking at our calculators? How many ways? 1, 2, 3, 4, 5 for each of the 24 arrangements here. So 5 times 24? Yeah, we can get the calculator, right? Okay, and you get the point, right? Okay, so my question to you is if I had in this class? 2, 4, 6, 8, 10. Perfect. 10, 10. Is that right? Yeah. Okay. If I got you instead of these pens standing up here, maybe we should do this for the rest of the afternoon. How many ways could I arrange you in distinct objects in this line of mine here? All right. See if you can figure it out. Here we go. You might want your calculator for this. Have you got it? Okay, so what is the answer? Does anyone want to share? Has anyone got it? Yeah.
3,628,800.
I don't think we've got time for this. I don't think we can do this afternoon. Okay, so the rule for n distinct objects in a line is n factorial. Now there's a button on your calculator, I think, depending on what calculator you have, it'll be at the top near the on button somewhere. You might need to apply a shift to it, or you might not, depending on your version of calculator. Okay, so if you press 10 factorial, that will give you this here. Okay, have we talked about factorial before and what it means? Okay, let's go back to a simple one like this one here, where we've got 3. We say that there should be 3 factorial ways of arranging these. Okay, which is, on your calculator, 6. Okay, what does factorial mean? It means this number times the next one down, times the next one down till you get to 1. So n times n minus 1 times n minus 2 times etc. all the way down to 1. That's what it means. Okay, so 10 factorial is 10 times 9 times 8 times 7 times 6, etc. Okay, alright, so that's this bit here. Now let's talk about this. Let's say we were going to have a running race with these pens or something, right? And I've got all these runners, and I'm going to have a gold, silver and bronze scenario, right? Okay, so how many different ways could this go? Like if we're going to have some betting or something, you're going to go for the trifecta and say, oh, I'm going to place my bets on red, orange and green or whatever. How many different permutations could there be? Would you have a bit of a think about that? Come up with an answer and we'll just share our answers. No looking at your textbooks, just logically, see if you can figure this one out. Right, what answers have we got? You got an answer?
1/18.
What does that mean?
There's a 6th chance a player will get a medal, and then there's a 3rd chance that it will be gold.
I don't think you understand my question. My question is how many combinations can we have in first, second and third? You think 18? Okay. Sorry. Okay, I think it's 18. Okay. Alright, thank you. What do you think? 19. Was that just a guess?
I had an idea at first and then it ended up as a guess.
Okay. Good.
36.
Griffin.
120.
Good one. It's actually 120. Right, so well done. Okay, so let's look at these guys here. How many, so we want to go gold, we want silver, and we want bronze. Okay, let's fill up the gold first. Let's give the gold to somebody. How many different options are there for gold at this point when I'm picking someone for gold? 6. Okay? Right? 6. Once I've picked someone for gold, say this chap, I'm now going to pick silver. How many can I pick from now? Once I've already picked one, there's only 5 options left, right? Now when I go to pick bronze, how many have I got left? 4. So I've got 6 options to choose for my first one. Once I've chosen that, I've got another 5 options to choose for my silver. And once I've chosen my silver, I've got 4 options left to choose from for my bronze. 6 times 5, 30 times 4, 120. Okay, so this is called, this is this example here, so this is the second exercise, k objects from n distinct objects in a line. So in other words, we had 6 objects in our line, which is n, and we wanted to choose 3 of them, okay? We wanted to choose the top 3. How many options are there? And this is n factorial divided by n minus k. So, n factorial, how many did we have here? We had 6 factorial, and then we do 6 minus, what did we say? K was 3 factorial.